it going? No. All right. So overlapping triangles, but yesterday we had this problem, which is kind of like overlapping triangles because there's one shape with a bunch of different shapes all combined.
Yeah.
So it's our job to prove this. Do you want to do it like legit two-column proof, or do you just want to talk about it?
Talk about it.
Legit two-column proof?
Psych, legit.
Okay, so legit two-column proof. I'm going to write, or try and write all that stuff as one given statement.
Yeah, I tried that.
It doesn't matter how you do it. Here's a good way to do this. Triangle LNP is isosceles. I don't have a person. Try the other day.
Yeah.
There's three of us.
They're just developing their own.
With base NP, and then you can say MN is perpendicular to NL. You can say comma QP is perpendicular to PL. And then down here, ML is congruent to QL. 1 given. So to use a plan, what do I have right now? Or what has it told me right now?
Ooh.
Go ahead, Blake.
So line segment LP and line segment LN are congruent.
Okay, it hasn't told me that.
Yeah, but we can defer that.
We can justify that
Yeah.
because it says
it's
an
isosceles
isosceles
triangle.
triangle. So that's a good thing. Do I have an H?
Yes.
Do I have an L?
Yes.
Yes.
So I just need to prove the angle.
Can you make another step for like the L and LP?
You have to make another step.
You.
Alright, so this statement right here tells me that, but I don't have that written right here. ML and QL are congruent. That's my H statement. Okay? That is an H. But I don't have an L.
You also don't have your
So I should
write that.
write the L statement. Statement number 2. Line segment LN is congruent to line segment, I guess that's fine, line segment LP. The reason that's true,
Definition of isosceles triangle.
you could say base angle theorem.
You could.
Not really, but it would be alright. It didn't say anything about the angle. No, I'm sorry, you can't. I lied. I spoke too soon. You cannot say base angle theorem. Because I don't know anything about the base angles. So this is now my L statement. I'm almost done.
Oh, angle.
Okay, so they gave me an H statement. I used the definition to get my L statement, but I must state that they are right triangles.
Oh,
And then angle MNL and angle QPL are right angles.
So you have to say they're right angles
yeah,
too.
I have that written.
It doesn't say that they're right angles, it just says that they're perpendicular. So you must state, and I'm going to do this the cheesy way, hope you guys can get over it, because I'm being lazy right now. Angle N and angle P are right angles. The reason that they are right angles,
Definition of perpendicular.
a definition of perpendicular.
Could you just give them mark?
I forgot that step.
Does it specifically say that they are right angles?
Well, technically it does.
It does in the picture,
It does say that in the picture.
but that means perpendicular.
Okay.
In this instance, they're saying perpendicular, but we have to state right angles. Definition of perpendicular since they are right angles, then we can say statement number 4, triangle LNM and triangle LPQ are right triangles. Why are they right triangles? Definition of right triangles.
Yeah.
Because right triangles have right angles.
Yeah.
The definition of right triangles. So finally, I have an H statement, I have an L statement, I have right triangles. So now that I have right triangles and an H and an L, I can ipso facto. Now I can prove the triangles are congruent. So last statement, statement number 5, triangle NNL is congruent to triangle QPL HL, the HL shortcut. Tough, right? So HL is the shortest shortcut, but it could be the longest proof. Because you have to prove right angles, then you have to prove right triangles, then you have to have an H and an L. Okay? So that one was fun.
Does it matter which order you put it in though? Because I did separate given statements like spread out and like.
You could
but I
have
got
like
the exact same thing.
as long as this statement is last.
Yeah.
That's the only thing that has to happen. Everything else between statement 1 and statement 5 or statement 1 and statement 9 could be different. And you guys use that to its full potential in the quiz.
Thanks.
Number 16, here we go.
Oh.
Who used the HL shortcut? I would like to know how you did that.
I don't know.
I see how.
Miles, can you explain to me how you did that?
Well, yeah. So first I did all the given statements as one thing.
Okay.
Then I proved that LO is congruent to itself. And I went through the steps to prove that MO and ON are
How?
congruent to each other.
How did you prove that MO and ON are congruent?
Okay, let's see. Definition of bisector.
Well, it doesn't say bisects that.
No,
it
is it
says
the-
bisects
Because it bisects that angle and then they're perpendicular. So I wrote all this stuff down. It's a lot.
How did you know that?
Well,
Because you're right. How did you know that?
Well, because the angle is being bisected,
Right?
and they're being like connected to LO in the exact same way, so it has to be equal.
Are you guessing or did you know that?
I knew that. It just makes sense in my head. I know.
Your head is confusing, Miles.
So, Miles jumps into next week, where if you have an angle bisector, a point that is perpendicular to the side of the angle, these 2 points are equidistant across a perpendicular line from the side of the angle.
What?
So, if you have a line that is perpendicular to the side of the angle and hits the angle bisector, these two are described as congruent.
Sure.
Now, I pause there. If this is the given statement, right? Angle bisector. Does everybody agree with that?
Yeah.
Miles said reflexive property right here, right? Miles, side, angle, angle. Why did you go all the way through HL?
I
Did
don't
you
know.
see side angle, angle?
No.
But you used this angle to justify this, right? That's what you said, that you said these two are the same through all those angle bisector steps. So he went the long way and got to HL. Maybe I went the short way and got to side angle angle.
Yeah, I got really lazy.
So good, but I don't think anybody else knew that or could justify that until next week when you have to know that. But right now, That's a stretch for us. That's why this one was tough. So, like we talked about earlier, and I said, "Did you see side angle?" And he was like, "I wanted to do HL because it's on the HL homework, right?" You guys get like cornholed into HL.
Yeah, that's why I thought I did it wrong.
I would do side angle, but you could use HL. And all you have to do is right here is say definition of an angle bisector. Those two are congruent. We didn't know that. So do you want to see all of it, or does that kind of like a good
That counts.
conversation? Which way do you want to see it? The HL way or the angle side angle way?
I don't care.
HL,
I-
I see
wait.
the
Can you do the side sideways?
If you
Uh,
prove that, yes.
No.
And
No.
These there's nothing in the angle bisector clause that would say okay, yes, you could do the side shortcut, but that would be infinitely longer than the HL shortcut.
You have to prove so much stuff.
So you want to see the HL way or the side angle way? HL way. I'm gonna do this. I'm gonna cheat. Maybe I'm gonna try.
Nice.
Okay, is everybody cool with that?
Yeah, why didn't I do that?
Because you can't do that on your test. Just
Dang
FYI.
it.
What
Yeah.
is on this?
That's all my given statements. So in that statement, you should or would have to write statement number 2 that angle MLO is congruent to angle NLO. Definition of angle bisector. That proves these two things are congruent. Now, while we're talking about angle bisectors, I'm going to continue with that. MO is congruent to ON. Because of the definition of an angle bisector. Yeah? Seen it? Huh?
That's what I put on my paper.
And it is right, but you didn't know that, and I just told you it was right.
Guess not.
So, statement number 4 should be LO is congruent to LO. Class responds with
Yes.
reflexive property. So right now you have an H statement, you have an L statement. Angle ONL and angle OML are right angles. Definition of perpendicular. This, y'all chose the HL shortcut.
I did.
We did.
No.
I chose it for you. Triangle ONL and triangle OML are right triangles. Definition of right triangles. So now you have an H statement, you have an L statement, and you have a right triangle statement. Triangle LMO is congruent to triangle LNO HL. Yay, math.
Yay.
Yikes, tough, right? Yes, sir.
Do you have to state step 2 before you can state your step 3? Because
You do have to say that those angles are congruent because it's an angle bisector. You have to say that they are congruent before you can say that these are congruent and before you can, yes. Does that answer your question?
yeah, but why do you have to do that? Because
Why do you have to state these angles are congruent?
yeah, because couldn't you just state that that MO is congruent to ON with the definition of an angle bisector without proving the angles? Because
Specifically with that, you need two things. To know that this is congruent, you have to know these are the same, or to know that these are the same, you have to know these are the same.
Okay.
So it is an angle bisector, but you have to know one or the other. So this could theoretically be the converse of the angle bisector, but that was a little much for us today, so we just kind of said the same thing. And we will talk about angle bisectors for an entire day. Because they're my favorite. No? Alright. Alright, so moving on with today's learning.
Or wait, that wasn't our learning.
That was yesterday's learning. Here we are today. Do you see this on your paper?
Right here.
Alright, so here's an introduction to overlapping triangles. Sometimes you can prove one triangle or one pair of triangles congruent and then use CP/CTC to prove another pair of triangles are congruent. So we started with, can you just use one shortcut to prove one set of triangles are congruent? Now we're saying, can you use a shortcut to prove one pair of triangles are congruent? Then use CP/CTC to prove another pair of triangles are congruent.
Okay, wait a second. What? Back it up. That's confusing.
Let's.
So we started with, do you see how many triangles are in this picture?
Yes.
1,
2,
3.
Oh. 4.
5.
Yeah, 5.
4.
What's this one?
Three.
Oh.
Oh.
1, 2,
That's a
3,
lot of
4,
triangles.
5.
So the part that sucks here is a visual puzzle, okay? You must figure out what you're trying to prove is congruent. At the end of the day, I'm trying to prove these two triangles are congruent. I'm going to highlight those to highlight them for you. At the end of the day, I'm trying to prove that Honest Abe over here and this illegal triangle over here are congruent.
It's in Texas. Isn't it? I don't know.
Wait, what?
So, at the end of the day, I'm trying to prove these two small triangles are congruent. If you look at those two triangles right now, is there any way to directly prove they are congruent?
Side angle. No, wait, that's ASS. Psych. It's ASS backwards.
HL would not work because it's not a right triangle. But good thought. There is no way to prove those two triangles are congruent directly. But if I look at this triangle and this triangle, there is a way to directly skip to a congruency statement. Let's explore that through what the proof says.
Proof is.
So, that yellow's tough.
Pop my elbow. Lord, my arm went back. That one's pretty. Go right.
I have this triangle right here,
Oh.
and I have
No.
this triangle right here.
Whoa.
And right now, I have marked that this angle, this side
Cherry line.
and this side are congruent, and that these two angles are congruent. That's what I have given in the problem.
Wait,
And
Okay, the top goes from A to B, which is somewhere in the middle. I don't know where exactly that is, so I'm not going to mark it. Right? So AE and CD are congruent. Angle AED and angle CD are congruent. Given. Then it says, what happened to my letters? There-
No, we don't even have letters.
We don't have E and D, we have an EC.
Sorry, ED.
And
That would clear some things up.
Yeah, I was like,
open.
I know, I was looking, I was like,
My bad. So ED. It says ED is congruent to ED.
Reflexive.
The reflexive property. So now I have this side is congruent to this side. Do you see a...
Side angle side.
Whoa.
I have a side and an angle and a side. That is the side angle side shortcut. So why are these two triangles congruent?
Side angle side.
Wait, given.
Side angle side.
Oh wait, they're triangle triangle.
Good. Side angle side. Now, after our side angle side statement, can I justify that angle A and angle C are congruent?
CP CTC.
CP, CT, C.
I love saying that.
So I have just justified that this angle and this angle are congruent. It says AB and CB are also congruent.
Given.
That is a given statement.
And then this is the SAS.
Then now can I prove that this triangle and this triangle are congruent?
Yes.
By
SAS.
the side angle side shortcut. So by proving one set of triangles are congruent, I'm able to justify another angle is congruent, which helps me prove another set of triangles are congruent. It's just forever fun. No, just me?
You just it is.
No.
Well, I'm gonna fail.
Let's do the next
actually-
one.
Next unit there will be no proofs,
Oh my gosh, yes.
Yes.
but there will be constructions.
Oh my gosh.
That's
better.
That's a good trade-off. Why is your brain so twisted?
It's not.
Damn. Walker.
It's not.
He finds pleasure in our
Here is
failure.
an easier concept. Can you separate and redraw the two triangles?
There's two.
Oh, that's an L, not a. Oh, it's. Oh, wait.
There's like 6.
There's 8.
8. Close.
Wait, okay, wait, Jay. Whoa. Wait.
Well.
Okay, I see that one.
Oh wait, it gave us the triangles right there.
Okay, the first thing you must realize, I've given you the two triangles to separate and redraw.
Oh, I get it.
Oh.
But then
G, L, J. So you would take this triangle, you would separate it, and you would redraw it. Copy and paste. Okay?
I can't do it.
You would also separate and redraw H, J, L.
Magic.
That is something you will be expected to do today on your assignment. Does that seem
Oh,
complicated?
we can't
No.
copy paste on here, so you just draw it.
You would just draw the two triangles.
Okay.
I will model that for you. So, because you don't have electronic copies, it says separate and redraw triangles MRP, M,
R. P.
nailed it, in QS.
N. Q. What?
Wait, that's
Some
it?
pretty tough math going on here, guys.
that's the
That's it. Separate and redraw them.
You're gonna add me to it.
That's it. That's all I want. That is literally all I want. Facts. You're like, there's
there's a
got to be
twist.
more. No, there's no twist.
Okay.
Are you sure?
Surprised that we're this nervous. When you said draw a rectangle, we were like, oh, that's easy.
That's it.
Then you said add constructions.
You're right. I did forget something. There is more.
I told you.
Wow, okay, cool, thanks.
It's
Got
going to
my
ask
hopes
you, what do they share?
They're both triangles.
Okay?
Oh.
So,
Okay.
if I uncopied and pasted it,
They both share.
A baseline
They
segment.
share triangle KLJ. No?
Line segment LJ.
they share LJ. That's what they share.
Oh, wait, no, that's right
but they share LJ. Now, if you couldn't get there from the awesome colorful diagram, you could also do this. This one has an L, this one has an L, this one has a J. They share LJ. Different strokes for different folks.
Wow.
Okay? Now that you know how easy it could be. Yes, sir.
Why is it not point K?
It's a geometric figure. So triangles have pieces. They don't have, like, I'm asking for what side or angle do they share? Because that's how the homework asks for it. What side or angle do they share? And it is color coordinated on the homework too. Do they share anything here?
Line segment S. Wait, no. Line segment RQ.
They share a little piece right here, RQ. That doesn't really help us much, but it's good to know.
No.
FED and CDE. So you can separate and redraw them, or you can just identify what they share.
ED.
Line segment E.
They both share this line segment down here.
Alright.
The last one. The last one.
Yay.
Okay, now, if you wanted to cry because it was entirely blank, I might have sympathy for you. But
And
most of it's
conflict.
filled out.
You don't.
I don't have sympathy for you. God, this is what the regular class did. You are the pre-AP class. You should be, thank you. Oh my God, there's numbers, there's blanks. I know how many steps to take. I know what the statements are. All you have to do is provide reasons.
Dang.
Given
There's more.
A, E, G, and A, F, D are congruent. I'm going to mark that down. A, E, G, this angle, and A, F, D, this angle are congruent. You know that A, E, and A, F are congruent. And you know that G, E, and F, D are congruent. G, E.
What?
Confusion abounds.
Yeah.
If you were to separate and redraw the two triangles I just described, it might be a little more clear. So if I drew A, F, D, A, F, D, I have right now that AF is marked, angle AFD is marked, and side FD is marked. The other triangle looks like this. A, E, G. It says AEG is the same as this angle. It says that AE is the same as AF. And it says that FD is the same as GE. Does that clear it up a little bit for you?
Yes.
Do you see a shortcut in the two triangles I have separated?
I say yes.
Why is triangle AE? Oh, sorry. That's not even fun. Why are these two triangles congruent?
Triangle sides.
The side angle side shortcut. Why is AG and AD congruent?
Maybe.
So right now I know that this piece is congruent to this piece. I'm going to mark that over here. This piece and this piece are congruent. Why are G and D congruent?
Wait.
Because of CPCTC. GE and FD are congruent. Why does GF plus FE equal GE and FE plus ED equal FD?
Segment addition.
Segment addition postulate. Is anybody concerned why we're not proving AFG and AED are not congruent right now?
Because
Do we have a way to prove this triangle and this triangle are congruent right now.
No, because we only have side and angle.
We have angle side side.
Yeah. That doesn't prove SHIT.
Right.
Yeah.
So I must continue. Why is GF plus FE equal FE plus ED?
So,
Transitive property.
yeah.
And then you subtract FE from both sides, and you get GF equals ED. So I have come to the conclusion that this piece and this piece are the same. And why are those two triangles on the outside of the big triangle congruent? The
SAS.
side angle side shortcut.
SAS.
Are there overlapping triangles in your text?
Yeah.
You will not have to do multiple shortcuts in CBCTC on your proofs. But you do have book work today. Do we have time?
No,
No,
no, no, no.
Well, no, if you said
Oh,
one.
darn.
Yes.
There's always tomorrow.
There's time.
Go get a book.
I need to turn it on for work or even.
What?
You need to
What?
turn it
What?
on.
Shh.
Come on. Come on.
There you go.
Go get a book.
Oh, that's what I meant. Okay.
What?
You got me a book?
Yeah, I got you.
You get Howie one too?
That's not free.
I hate it. They're so
Please turn to page 118 in your Bibles. Your math Bibles. We're about to do the gospel.
Let's see hallelujah, man.
Amen, brother.
Oh.
You're in the wrong church.
This is Baker's church.
It's Baker's Bible.
It goes